So the algorithm says, right, this is 3, no question. But here, 1 minus 8, go, right? So make it, you borrow 1 from here, and then it becomes 11. Up here. Then it becomes 11 minus 8 is 3. 2 minus 0 is 2. Now, this method of writing, I think everybody knows, am I right or wrong? You all get it, right? So now I will tell you the traditional way of doing it, or what did I say? Traditional convention. Right, let me show you how that, in case you have any doubt. So it's 315 minus 82 is what? It's 3 times 10 squared, right? Minus plus 1 times 10 plus 5 minus 0 times 10 squared plus 8 times 10. I put this in because some of you may be somehow misled into thinking that, well, 3 terms minus 2 terms, I don't know what to do, but the 0 term is always, the 10 squared term is always here. So that's 0 times it, right? Now, the identity A that I said should be this minus this, this minus this, and this minus this. And everything's okay except the middle, where 10, 1 10, you're not minus 8 10. Right? So what you say is what?
2.
This is
2 times
2 plus 1. Let me do it slowly, right?
2 plus 1.
Plus everything the same. I'll spare you of seeing that. So that would be equal to 2 times 10 squared plus 1 times 10 squared. Now I write it over, write it up because I need to do it. All right?
Yes.
Am I too fast?
No.
You know, I never used to know how fast I write until I realized it's much easier to write on the board than for you to write on a desk. I can write much faster.
Really?
You know what you're writing.
Huh?
You know what you're writing, but we don't necessarily know.
Right, okay, that too. Now, watch. Here is a sum of 4 numbers, right? And so you remember.
Yes.
It's like collection of numbers on an add. I can add any which way I want. Therefore, anticipating what we're doing, I want to group these two first. Because when I do that, then all of a sudden I have a sum of 3 terms. Compared with the sum of 3 terms here. Then identity A, tells you this minus this. I hope we can do it by sight. That's 2. This, no matter how you look at it, is 110, right? Minus 80. It's 30. Right? 5 minus 2 is 3. That's 230. All right? That's good.
You made a jump there. Would you normally do that, or you just do that at the same time?
No, normally I won't do it. So, I mean, I would write it and then write it again. But it's too much for, it's too late in the day.
I'm missing something here.
But the
Yes,
one,
yes?
skip one.
Say it.
No,
What is it?
I'm missing, I wrote down, I have this, the 1 times 2 times 10 squared plus that, right here. So, and then that term.
Well, we had it like this, remember? You don't disagree with this, do you?
No, I see that it's 3 10, right?
Right? This is distributive law. I'm using distributive law here.
You subtracted the 80 in the air somewhere.
No, I did not subtract any.
It's
What
not
did
on the board.
No.
What did I subtract?
So what helped me a lot there was that 1 times 10 squared
Yeah?
is 10 times 10.
Oh, it's 100.
Yes.
Yeah.
If you change that to 10 times 10 plus 1 times
Okay,
10
it's 11, 10.
Yeah, it's 11 times 10.
Yes.
And then seeing that 3.
with the 8
Yeah.
tens, then you can subtract.
They ended up with 3 10s.
You're absolutely right.
Saying, this is not 3 10.
So for the record, could you just put that in the one, underneath the 1 times 10 squared, to put 10 times 10 squared?
No, the whole point is the same labor. What are you doing? You get in trouble or something?
We're enemies.
Yeah, exactly. That's all.
You'll hear about that later.
I know.
See the after class.
Plus 11.
Okay.
Thank you. Yes.
Oh, very good. Very good.
Now you're part A, yes? And it's really 0, right? So it's 2. Right? 11 minus 8 is 3. Right? That's 6. Everybody happy? Now let me, before I let you go, I want to address one of these. Okay. The other thing I can leave it tomorrow, but this I want to address right away. Now there are all kinds of strange things out there, and I don't doubt that they'll be here, or they're still here, or they will be here at some point. And you should be prepared. You notice that when you write the numbers from left to right, right? 1, 3, 10, you say 3, 1, 0. You don't say 0, 1, 3, right? Let's look at like this. 3, 1, 5 would be, yeah, let's make it 162. 167. Let's put it there. Right? Now, what I'm trying to say is that you say 3 and then 1 and then 5. And then 1 and then 6 and then 7. Left to right. But when you do the algorithm, we don't say, what is this? 2. What is this? Oh, let's go back. We don't do that. Instead, the algorithm, by definition, is from right to left. Now, I don't know if you know. Tell me. Do you hear that this is one of the battle cries? That this is an unnatural act inflicted on children so that they lose their sense of what a number is, because everything from left to right. And all of a sudden, they're asked to do things from right to left. Natural, perturbs their natural sense of what a number is. Therefore, standard algorithms should not be taught. Heard this? Yes. How many of you have heard it?
I've heard.
Okay, so half. I know you never heard it. Really? Anyway, so So now I want you to understand why we do this. First of all, there's an issue about children. The fact that you think that by making children do something slightly unnatural, what do you call it? It's going to do them permanent harm. Does anyone believe that?
No.
Have you seen them do video games? You think that's very natural? So, I mean, this is how silly the whole discussion has become. Just because when you don't know mathematics, you will just seize on anything under the sun and start a fight. That's what it comes down to. But you can see perfectly well why we don't do from left to right. You know the reason, right?
Yeah.
You can do it, but you backtrack. And if I want to hold a problem, I think you have to actually do it yourself. Well, let's try to do it from left to right. Is there anything wrong with it? Absolutely nothing wrong with it. So you say it's true. And you come to here, you say, uh-oh. All right, so you say no. All right, so you rewrite it over again. So this is not good. All right. So I know I need to transfer something from here to here. Right? So therefore I say this is 2, and then this becomes 11. Now do it all over again. 2, 1 is 1. 11 subtract is 6. 6 from 11 is 5. Right? And you say, oh. So you say, no, let's do it over again. So you do it over. So you say 3, 1, 5, 1, 6, 7. So you say, but you know that's not going to last, right? So you change the 11 to what? 10. Now this becomes 15. But you start all over again. So you say 2 over 1 is 1. 10 over 6 is 4. And then 15 over 7 is 8.
But why not do it at the bottom?
Why not, borrow from your
Borrow
difference?
from the bottom. Yeah.
Borrow from what difference?
In the first problem, take from your 200.
Yeah. Change the 2 to a 1.
2 to a what?
A 1.
I'm sorry. 2 to a what? What was the 2?
Change the 2 to 200. No, the first one. The first one. Go to your left. Left.
Right.
Yeah. Change the 2 to a 1.
Change it to.
But that's not the algorithm.
No, well, you need to. Okay.
No. You missed the point. The point is, if I do it strictly according to the algorithm,
Oh. Okay.
right? Why do you go from left to right? It's not about whether you can find tricks to salvage the situation. It's not. You're trying to say, if you do it according to what's required of you, from left to right, what's going to happen?
It's exactly the same thing. You've done, instead of changing, instead of doing different numbers, and running it over again.
What is meant by exactly the same thing?
Okay.
Same thing between which two
The same
things?
thing between what you're doing is your trading, right? This trading of the 100 over to the tens column.
Mhm.
So you're trading the hundreds to the tens column, but you're crossing out the 2 down there and putting a 100, up there on top of that 1, making it.
That is way too confusing. You can't do that. You are down here already, and you go right back up.
That's just as confusing.
No. You missed the point. You missed the
No,
point.
she's just trying to see
Remember
instead
Raul
of a
showed us how to do it in Mexico, and it's very similar to that. They work from the book. But it's a
All right.
different algorithm.
All right.
Yeah. It's
The point is, why he's saying that we should go from right to left,
Yeah.
right?
Yeah.
Why don't you go from left to right? So that he's showing why you should take. And so,
Are we all on the same page? So that's all there is to it. You don't do it for what reason? You don't do from left to right for what reason? Wow, for the man, a little stupid. No, there is to it. So, you show the children what they say, this is the mess you get into when you do it from left to right. So why don't you grow up a little bit and do it from right to left? Nobody will have a problem with that. Don't worry about it. Okay, so there's some tiny little things here and there, but we can do it tomorrow. But basically, we got the subtraction algorithm down. All right? So time for eating.